Okay, so here we are. So we were finishing discussing about this piece of software here. Okay, so in processing, we said we have functions which are similar to the Arduino. There is the setup function, which runs only once. And then there is the draw function, which is the function corresponding to the loop function in the Arduino. So this thing will run forever. And what it does, it checks if there is data available, and then it moves the dot of the this green line of this virtual oscilloscope by incrementing a variable here. So the way that this green line is produced is by drawing it pixel by pixel. Actually, not pixel by pixel, dot by dot, let's say. From one dot to another dot, it draws a segment. Then from this to this another segment, from that to that another segment, and so on continuously. So here you can find some logic. So for instance, you see data of I would be, let's say, an index that is incremented each time a piece of data has been read from the serial port. So data is an array of data, and it is assigning the value of that array to the y coordinate of the A dot at the point A, and the subsequent data is assigned to the y coordinate of the B point. So you have one point here with a certain value, another point here with another value, and the program will draw a line with this instruction line: xa, ya, xb, yb. So drawing a line from these two coordinates to those other two coordinates. And then it also prints the value of the y-axis, the current value, to the log file. Then we have this function, serial event, which is similar to the one we can find in the Arduino. So this manages the serial port. So it is reading bytes from the serial port. So who is writing those bytes? Arduino, continuously. So this thing, whenever a byte is written by Arduino, this serial event function is activated, and it reads it and it puts it in data. Then we have something related to the graphics, which is this thing. Sorry, I have to go here. Okay, these are what are called the Gui Callbacks. So the graphics user interface callbacks function. These are functions that are invoked every time you do something on the graphical part of this application, which means when you click the buttons, basically. If you click the button number A, this is what it will do. If the Arduino is present, this is just a check, it will write this one code. This is a keyword that Arduino knows because we program it that way. So when it receives from the processing this value, it knows it has to do something in order to set this sampling rate, and similarly for B it sets another sampling rate and for C, while the last thing is the button D, which corresponds to the exit button. So before exiting the code, we flush all the data we have on the log file, we close the file, and we exit the program. Okay, so that is the thing. And now the funny part, the electrodes. So here we have the electrodes. So take them, they are like this. There is this thing, water, and the conductive gel. So let's try to open one electrode. So you go from here, you take it, and it's like this. If you want, you can put it back also. So you can just put it here and you can reuse it for later. Now let's try to inspect those electrodes. So they are very useful. So it's a scotch tape patch. They have a button here, I mean button in the sense of a physical metallic object like this. And so now I have to take something in my hand, so I put it back like this. I go here, I disconnect those things. So those buttons are supposed to be connected electrically like this. You see? So you open the alligator clamp and you clamp this thing. That's it. So we do this now. So before we apply the electrode to my skin, let's verify if they are wet or not. In my case, if I touch it with my finger, so this is a little sponge which should be normally soaked with the gel, so this is completely dry. And also if I press it gently, I can feel something like a solid part, which is the gel that is completely dehydrated. It means that those electrodes I have are not new, let's say, probably they are old, but they are not damaged, they can be easily revived. You just need to put a drop of water, and in case you can put a little bit of gel. So let's try to do this. So now I move this iPad so we can have more space for this operation. I put it here, then I open the tube with the water. This is just tap water, there is nothing special. So I open it like this. You can use this, for instance, or whatever thing you want, your finger even. So you take a little bit of water, you put it here, maybe you can also do like this. You put this like this, and then carefully you do like this, and now you have some water on it. Then you close this, then you do something like this a little bit. So we mix the water with the gel and we try to revive this electrode like this. You see now the water is melting the dry gel. You can also use your finger, there is no danger in doing this. Okay, you mix it like this. Then if you do like this, you will feel that it's a little bit slippery. So this is the gel. Okay, so let's say that one electrode is ready. Then you need maybe a piece of tissue in order to clean your hands. Okay. And now we have to connect the electrodes on the skin. So it's just a piece of tape. So Scotch tape, we don't need anything special to do this. But in case you can also add some extra tape. I suggest you to find something like this, which is a paper tape that you can easily manipulate, and add some extra tape in case you see that the glue on this patch is not sufficient. So you go here, you take your arm. Now I do something like this. I want to use a lens that I have here in order to show you better what I'm doing. So I add a lens in front of the camera. It's a fisheye lens, so the image will be a little bit bulged. But now the field of view is bigger. So here is my arm. So you go like this. So this is the bicep muscle. You can use any muscle you want, but of course this is much easier. So the idea is to attach one electrode at the beginning and one at the end of the muscle. So you have a maximum voltage displacement. And the reference into a place where you don't have a muscle. But it's difficult because in the human body, the human body is fully covered of muscles. There are a few places where you have no muscles. One is this one, for instance, close to this bone here. So we can attach one electrode here like this. So you just firmly press. You can do something like this. Okay. And then we put another here and another here. So let's prepare the electrodes. So again, we take the water tube, we open it, then we also, this one is dry, so we soak it with a little bit of water. Let me remove the lens so you better see this preparation. Again, we do this. We mix it a little bit so the gel is reactivated. On the back of this electrode here, this is the top, this is the back, you see the silver chloride part of the electrode. So this black spot you see underneath the sponge, that is the true electrode. So what is here on top is just a layer that facilitates the connection between the metal and the body. So now I have this one, and I can put it here like this. Okay. And now let's prepare the last one. In the same way, so I soak it with water. mix it a little bit like this. So let's try not to spread the water all around the patch, because maybe that will interfere with the scotch tape, and then the adhesive will not be so strong. In case, you can just add some extra tape. Okay. So I attach this here at the base of the elbow. The placement is not critical. The important thing is that the electrode have been soaked with the water, so they are the gel is liquid, and they are attached to the skin. Okay. So now let's connect the electrodes. We said that the black one was the ground, and the ground goes here where you don't have the muscle. And then signal and reference goes to the other two. We can flip them the way we want. It's not important. The only thing that will change is the polarity of the signal. Okay, so now I am connected. I try to put the fisheye lens again. So you see the connection. It's something like this. So now I can relax my muscle, or I can contract it like this. Relaxation and contraction. And let's try to see if it works. So I put the iPad here, then I open this, let's see what happens. Let's try to find the track, because now I moved this. Okay. Now I try to disconnect it and see whether I can find the track again. Ah, sorry. Maybe the Arduino is open. Let's close it. Now I have to recenter it. Now I try to rerun it. Okay, here it is. Okay, so I reconnect myself. Okay, so now I change the scale. I try to adjust the trimmer in order to have the signal centered. And now I have to disconnect the power supply of the computer in order to have less noise. And let's try to contract the muscle and see if I can see the signal. Let me move this. I also want to sorry. Okay. Okay. I have a little bit of noise. You see this 50 Hz noise. So let me try to turn off something I have here. Now it's a little bit better. Okay. Then you see that when I contract the muscle, it is measuring some contraction. Let me try to turn off something else. For instance, I disconnect the iPad, power supply of the iPad. No, the light is not making much noise. I can try to press the electrodes a little bit better. So let's try to make another contraction. So this signal that is changing is superposed to this sinusoid. Let's try to change also the scale. Now I'm at 19.2 kilohertz. Now I remove the lens so you see better. So now I contract. Now there is a small signal superposed to this. Every time I contract, like contract, release.
Sorry, but I am getting no signal.
I show you better. So you see this kind of underlying sinusoidal signal that is running. When I contract the muscle, you see that it starts moving differently. Now I contract more, then I release. Now I contract more, then I release. Let me see if I can make it better somehow. Now I'm moving the trimmer. Okay. So this is the type of signal that one might have. Another thing that I can do is I can oh, sorry. Now I know the thing. I'm not connecting my Arduino to my laptop computer, but it's on my big computer, which is not a laptop, and so it's not connected through a system that is running on batteries. So I have to do one thing. This is why we still have this oscillation, because it's picking up from the mains. So what I do now is I stop this thing here and I go directly on my laptop. So I stop this screen sharing here with this remote client. Then I bring my laptop closer and I run this. You probably lost the video, but now I will put you in different screen share. So okay, let me connect the cable of Arduino directly to my laptop. So I need a different USB cable. Okay, just one moment, I disconnect the cable I have here. Okay. Let's connect it like this. Let me activate the program on the laptop. And then I share the screen with you. Okay, just a moment. Serial plotter. I'm opening the processing on my laptop. Takes a while. Okay. Okay. Now let me move the laptop here. How can I do it? Let's try do it like this. And now I activate the screen sharing. Zoom. Share screen. Processing.
Sorry, Erik, I want to ask something.
Yes, please.
So, by turning the knob on this resistor, I initially had it right in the middle, so for a voltage of 2.5.
Okay.
And at that level, the signals I was getting were pretty much like saturated.
Yes, you probably can turn it differently because Arduino is not amplifying a signal starting from a baseline at 0, or let's say, sorry, at 2.5, because the range of Arduino is reduced, the ADC range. So it might be that you have to set it a little bit higher in order to have the track in the middle of the screen.
Okay.
So maybe I was not precise in saying this about the 2.5 volts. The 2.5 volts is good for the simulation because there is no Arduino attached to it, and so the signal is perfectly symmetrical. But in the Arduino case, the input range of the ADC is a little bit shifted up, so you probably have to move it. So can you see the screen in this
yes.
laptop? Okay, so now I try to put the electrodes back on my arm. So I put the black one here, the red and this, and now I have to probably change the level of the trimmer. Okay, let me see. So this thing was not programmed that way. Okay, I have to first center the line, so I want to short circuit those things all together. Okay, let's check all the connections. Okay. Okay. maybe it's still a little bit noisy. Okay, let's try like this. Okay, no, it still looks, it's a little bit saturated. Let me first move the laptop because I have no access to the circuit, and then I will reactivate the screen sharing in a moment. Okay. I see I have an old version on my laptop, so I want to re-download the new version of this serial plotter. So I should have it here. Serial plotter. No, that's an old version, so let me re-download it from the GitHub pages. Okay, so I go circuit codes, download the zip file. Okay, I am downloading the zip file. Still a little bit to download. Okay, the download is ready. So I go here. Where is it? Download. Okay, unzip it. Here I have it. Processing, serial plotter, serial plotter. Okay, now I should have on the laptop what you have there. Okay, the serial port, I have to put the serial port. Okay, it should be number 2 probably, according to what I see here. So let's say I change it like this. Okay, now I see the line on the screen. Then let's connect everything together. And let's try to set the trimmer half of the way. Okay. And let's try to reconnect again. And see if we are more success. Okay, I don't know whether you can see the contraction of the muscle now in a higher magnification.
No, we can't see.
You see the line is now kind of flat.
No, we can't see the line.
Ah, you can't see the line. You don't see the screen. Okay,
No.
let me do a better screen sharing. If I share, can you see the desktop now?
Yes.
Do you see the desktop?
Yes.
Okay. Let me try. Now you see?
Yes.
Okay. There is a little bit of delay when I do the contraction and where you see. I guess because I'm streaming this with the computer, so probably the CPU is overloaded. So when I contract and I release it, then you see the result like 1 second delay. I was not expecting this, but I don't know if you can hear the fan of my PC, of my Mac. It is kind of flying as much as it has been. So this is the type of signal you should be able to see when you contract the muscle. I'm trying to contract it for a long time now. Let's see if I can. So with the delay you will find the signal. It's difficult for me to stay there for a long time. Okay, so now I stop this because I'm kind of getting a cramp with my muscle because I'm doing it for a long time. So ideally, if everything works, you should see a time varying signal of that type as exactly when you contract the muscle. So the thing that was confusing the result of this display was that I was connecting the computer, the USB to the computer, the desktop computer, which is directly connected to the 220 volts 50 hertz mains, and so it was picking up some noise, this kind of slow sinusoidal that was overlapping everything, and the amplitude of that signal is much bigger than the one you have in the muscle. So what I suggest you is to try to do this experiment with the laptop having the battery, the power cord disconnected, so you run on batteries in a way I was doing right now for this demonstration. Okay, so sorry for this unpredicted real-time modification of the setup. This signal you see, these are not spikes, so I'm not recording only from one neuron. You don't see this beautiful stereotypical action potential. In order to see this, you have to go inside the neuron, I mean close to a neuron. So I should put the electrodes somehow inside the nerve and in one single fiber of the nerve, which is a little bit difficult. So what you get here is an average value due to the activity of all the neurons that are driving the muscle, the bicep muscle, and there are many fibers, so they are of course correlated together, because when I contract my muscle, I'm contracting all of them, but they are not receiving exactly the same signal, and still the electrodes are averaging a lot of signals through the area. So what you should expect to see is a sort of average signal that goes up in amplitude. The higher, the more you contract the muscle, and that should be something like the average of the postsynaptic trail of the action potential, because maybe the average of the spikes are something like 0 or something like that, because they are random, they cancel each other. Those are the individual events are not exactly correlated each other, but on average you will see the amplitude increasing. So for the moment that's it. Thanks.